If you collect a random sample, you have many data points. Now let's have a look at data measures. So including 3 categories of measures. The first category is the location. Location is also called central tendency. That means if you plotted the histogram of the data, where it is located, where is the mean, on average, where it is located. So including mean, median, and a mode. And the second category is dispersion. That is measurement of the spread of the data, including the range, variance, standard deviation, mean absolute deviation. The third category is a shape measure, skewness. Is it positively skewed or negatively skewed? Skewed to the left or skewed to the right? And also the shape, the kurtosis measures the shape of the data. The first location measure is the mean, the arithmetic mean of a sample, or simply the sample mean of n observations x1 to xn, denoted by x bar, is computed as you add all the observations together divided by the sample size. For example, here we have 10 observations, and they are collected by random sampling from a population. Then the sample mean x bar will equals to, we sum all the observation values together and divide by the sample size n. So this will equals to, we add 143, 141, 140 to 142, and then we divide it by 10. So the sample mean is 141.2 millimeters. Okay, the second location measure is the median. Median is defined to be the value which divides the data into 2 equal parts. That is the middle value. So half of the value are above it, and the other half are below it. To obtain the median, we sort the data from the smallest to the largest. For example, the previous data set, this data set, we sorted from the smallest to the largest. We will have x4 is the smallest, x9 is 139, x8, 143 is the largest. So, but here, if we find the middle is actually right between the x6 and x5. So in this case, we take the average of these two. So it will become 141.5. So if we have all the number, for example, this is 145. Now the middle value will be right here, then the middle value will be 142. The median will be 142 because we have 5 here and we have 5 here, and this one is the middle value. The third location measure is mode. The mode of a set of n measurements x1, xn is the value of x that occurs with the greatest frequency. Or you can say the most popular common value. So in this example, we can see that we have 139 appear twice, 141 occurs twice, and 142 occurs 3 times, and 143 occurs 2 times. So the mode, the greatest frequency, this 142 appears 3 times. So the mode is 142 for this data set. Now let's do an exercise together. Suppose the data set consists of the following observations. What is the mode? As we can see, 0.32 or 0.50 only occur once, 53 only once, 28 once, 37. We don't see any other 37. But we see 0.43, 0.43 appear twice, 47, now 36 once, 42 once, 38 once. So the mode is 0.43. Now let's have a look at the measure of dispersion. The simplest measure of the spread or variation of a set of data is the range. So which is defined as the difference between the largest and the smallest value. Of course, the range is the maximum minus the minimum. Although the range is simple to use measure of variation, it only uses two extremes of the data set, the maximum and the minimum values. Thus, it is significantly affected by extreme values or outliers within the data. So in this case, we have the maximum 143 and the minimum is 139. So we take these two values and we take the difference. It's 4 millimeters. The second measure of dispersion is based on the idea of measuring how far on average the observations are from the center of the data. So sample variance. Here, sample variance is the square deviation from the center of the data, and then we divide by n-1. So this is the measurement sample variance. All the other summary statistics we have considered are in the same units as the data. Thus, a better measure for practical use is the square root of the variance called the standard deviation. So we take the square root of sample variance. We got the standard deviation. Why we take the standard deviation? Because the units is the same as the data because you take the square root. Otherwise, the sample variance is measured in the squares of the units of the original data. The third measure of the dispersion is mean absolute deviation. The average of the absolute deviation around the mean, as you can see here, and we have summation of xi minus x bar and the absolute value, and then we divide by n. This is mean absolute deviation. So let's have a look at an example. A student posted 6 pictures of her dog online. Here is how many likes these 6 pictures each received. So 10, 9, 11, 8, 12, and 10. So we calculate the mean. And then we compute the distance between each data point and the mean. And then we compute that we add all the deviations together, the absolute deviations around mean together. And then we divide by 6, which is equal to 1. So that's the mean absolute deviation. So the third category is the measurement of shape. The first measurement is skewness, the first statistic. So as we can see, the data could be right skewed, then you got a positive skewness. Can also be like a left skewed, then you got a negative skewness. So if the data distribution is not symmetrical, then we call it asymmetrical or skewed. So skewness characterizes the degree of asymmetry of a distribution around its mean. And skewness is calculated using this equation. The second measure of the shape is kurtosis. Kurtosis characterizes the relative thickness or flatness of a distribution compared with the bell-shaped distribution, that is a normal distribution. So kurtosis is computed using this equation. So if kurtosis equal to 0, is the shape is approximately bell-shaped in the middle. If it is greater than 0, then you got a high peak. If kurtosis is less than 0, you got a flat-shaped distribution.